Hello and welcome to our project demonstration. In this presentation, I, Ramin Suraya, and my group member Manahil Asad will walk through how we analyzed inflation patterns across Pakistan's major cities using CPI data from 2023 and 2024. CPI data is a crucial indicator because it reflects changes in the cost of living and helps us understand where inflation pressures are strongest across different regions. Traditional CPI comparisons, however, often fail to capture the deeper relationships between cities. This is why we incorporated cosine similarity and network analysis. Cosine similarity allows us to compare the shape of price trends rather than just absolute values, helping us identify the cities that move together in terms of inflation. Network analysis then visualizes how cities are interconnected through these similarities, making it easier to detect influential hubs within the inflation network. Together, these methods help us identify the cities that serve as major inflation influences across both the years 2023 and 2024. We begin by grouping 51 CPI products into seven well-defined categories. For each city and category, we constructed a 12-month price vector for both 2023 and 2024. These vectors represent how category level prices evolved throughout the year for each city and form the foundation of our comparative modeling. We used a dictionary for this. And then to prepare the data, we handled all the missing values, converted month names into numeric form, and applied z-score normalization. This standardized version ensures that the cities are compared fairly regardless of whether the absolute price levels are high or low. It allows us to focus solely on the structural behavior of the CPI movements. And then we computed the cosine similarity between every pair of cities and used a heat map for the visualization. Cosine similarity ranges from 0 to 1 and tells us how similar two cities' price movement patterns are across the year. A higher similarity indicates that cities' inflation trends follow very similar shapes. Then we applied similarity thresholds of 0.6, 0.7, and 0.8. Lower thresholds retain more connections, creating dense networks, while higher thresholds filter out the weaker relationships and reveal clearer, more meaningful clusters among the cities. And then finally, we used similarity values as edge weights in our network graphs. This means that cities with closer inflation behavior are connected with stronger links, which directly influences the centrality metrics we compute later. Then to load and to clean the CPI data, we started by loading the CPI dataset, filtering out the relevant 2 years, mapping individual products to their broader categories, and aggregating prices to create city category vectors. This pre-processing step ensures that the data is consistent and ready for further modeling. Next, we computed full cosine similarity metrics for all the 17 cities in each category and each year. These metrics quantify how closely cities' inflation patterns resemble one another. Then, using these similarity matrices, we built weighted graphs under multiple thresholds. We also implemented 3 weighting schemes. Number 1 was equal weights. Number 2 was importance weighting. And number 3 was the based weighting to observe how city influence changes under different assumptions. Structures that we used for this project are one was Panda's data frames to store and process all matrices, tabular structure, and we also used dictionaries, as I mentioned earlier, to organize data by categories and years for easy retrieval throughout the analysis. Then to compute centrality metrics for each graph, we calculated the four standard centrality measures. Number one was degree, which is the number of strong connections. Then it was closeness, average distance to all other cities. Betweenness, which is an important bridge between clusters. And then there was eigenvector centrality, which is the overall influence considering neighbor importance. Then the visualization tools that we used were heat maps, networks, and line graphs, as shown above. Now,
So
Manahil will tell
uh,
you about the visualization and comparison.
I'll be taking it over from here. I'll start by explaining the visualization and comparison. As you can see, the heat maps and the graphs and comparison plots. So basically, the weighted networks visually show how strongly each city is connected to the rest, with thicker edges representing higher similarity. Next, the weighting categories differently produces alternative network structures, highlighting how essential or volatile categories impact inflation connectivity. Uh, Next are the threshold sparse networks. So using higher thresholds like zero point 0.7 or zero point 0.8 isolates the strongest clusters of cities, revealing which regions share tightly aligned inflation behaviors. Next are the heat maps of similarity matrices. As you can see, the heat maps, they clearly show how groupings of cities with similar inflation patterns help us visually interpret clusters and outliers. Uh, Here is the visualization of centrality ranking shifts. Line graphs comparing influence scores across the three weighting schemes illustrate how city rankings shift depending on the assumptions applied. Across all these visualizations, we observe a consistent structures. Certain cities repeatedly appear in strong clusters and rank highly in influence scores. This highlights their stable importance within the national inflation network. Uh, Lastly, I'll be interpreting our results. So each weighting scheme emphasizes different economic realities. Economic weighting prioritizes essential categories and shifts influence to cities driven by core assumption prices. Volatility weighting highlights cities influenced by unstable or rapidly fluctuating categories. Some cities remain highly influential across all schemes, indicating a strong and stable structural role in the inflation network. Others shift positions depending on the scheme, showing their influence which is category specific. So, the effect of threshold variation. Higher thresholds isolate strong, meaningful inflation relationships, often involving major urban centers. Lower thresholds create broader, interconnected networks that capture weaker correlations across the regions. Next, I'll be explaining the reasons for changes in centrality scores. So, the cities with strong similarity across multiple categories score high in eigenvectors and closeness centralities. Cities positioned between clusters score high in betweenness centrality as they act as bridges between otherwise loosely connected regions. Next, the variance across the 2 years, 2023 and 2024. This reveals clear changes. Some cities grow more influential, indicating stronger alignment with national inflation trends, while other while others become less central. This suggests stabilizations or divergence. Lastly, the conclusion that we came to from this project. Our project successfully applied cosine similarity and network analysis to uncover inflation connectivity across 17 Pakistani cities. By exploring multiple weighting schemes, similarity thresholds, and network visualizations, we identified influential cities and revealed structural inflation relationships that are not visible through traditional CPI reporting. A few cities stood out as consistent national influencers, while others displayed category specific or volatility driven behavior. These findings often meaningful insights into offer meaningful insights into inflation dynamics across Pakistan. That is it for our project. Thank you.